The universe, that immense expanse of space that surrounds us, has fascinated human beings for millennia. From ancient civilizations gazing at the night sky, to modern-day astronomers peering through the lenses of cutting-edge telescopes, we have long sought to understand its origins, its nature, and its future. For much of the 20th century, our understanding of the cosmos was rooted in a relatively simple model, the Big Bang theory. This theory, which proposes that the universe began as a single point and has been expanding ever since, provided a coherent and largely accepted explanation for the observable features of the universe. According to this theory, the universe is about 13.8 billion years old, a figure derived from observations of the cosmic microwave background radiation and the distribution of galaxies. But what if that's not the case? What if the true age of the universe is far greater than we've been led to believe? What if, in fact, the universe is not 13.8 billion years old, but instead, closer to 26.7 billion years, or even older? This might sound startling, even implausible, but the latest findings from the James Webb Space Telescope have cast doubt on the accuracy of the established timeline of the universe. Webb, which launched in December 2021, is the most powerful space telescope ever created. It is capable of observing the universe in infrared light, allowing it to peer deeper into space and further back in time than ever before. And what Webb has revealed has left the scientific community reeling. Galaxies that were thought to have formed hundreds of millions of years after the Big Bang have been found to exist much earlier, and they're far more mature and massive than our models of galaxy formation would have predicted. These discoveries force us to rethink everything we thought we knew about the universe's origins, its evolution, and its age. They have the potential to upend the very foundation of cosmology and introduce an entirely new paradigm of understanding the cosmos. But before we dive into these revelations and explore what they mean, it's important to understand the current state of our knowledge and why these new findings are so groundbreaking. For most of the 20th century, the prevailing model of cosmology was the lambda cold dark matter, lambda CDM, model. This model posits that the universe began with the Big Bang about 13.8 billion years ago, an event that set the universe on its path of expansion. Following the Big Bang, the universe underwent a period known as the Dark Ages, during which there were no stars or galaxies to illuminate the cosmos. As the universe cooled, matter began to coalesce under the influence of gravity, and the first stars and galaxies began to form. Over the next several billion years, these early structures evolved, eventually leading to the galaxies and stars that populate the universe today. The lambda CDM model has been incredibly successful in explaining many aspects of the universe, including the observed distribution of galaxies and the cosmic microwave background radiation. It also provides a framework for understanding the expansion of the universe, the behavior of dark matter and dark energy, and the formation of galaxies. However, the latest findings from the James Webb Space Telescope suggest that there may be major flaws in this model, particularly when it comes to the age of the universe. The most surprising of these findings is the discovery of galaxies that appear to be far more evolved than we had expected for their age. These galaxies, which are located billions of light-years away, seem to have formed much earlier than current models of galaxy formation would suggest. According to previous theories, it should have taken billions of years for galaxies to develop into the highly structured, massive entities that Webb has observed. But these galaxies are already fully formed and contain a diverse population of stars, some of which are much older than we would have expected for a universe that is supposedly only 13.8 billion years old. This raises several important questions. Could the Big Bang have occurred earlier than we thought, meaning that the universe is much older than 13.8 billion years? Or could galaxies have formed much more quickly than we previously imagined, allowing for the existence of these highly evolved galaxies just a few 100 million years after the Big Bang? Another possibility is that we are seeing evidence of galaxies from a predecessor universe or even a parallel universe that exists alongside our own. While these ideas may sound far-fetched, the evidence presented by Webb's observations is difficult to ignore. One of the most striking discoveries made by the James Webb Space Telescope is the identification of 6 extremely old black holes that seem to have formed only a few 100 million years after the Big Bang. These black holes are far older than we would have expected given the current timeline of cosmic evolution. According to the Lambda CDM model, black holes of this size and age should not exist so early in the universe's history. This finding further suggests that the current model of cosmic evolution is incomplete and may need to be revised. The implications of these findings are profound. If the universe is indeed much older than we thought, it means that our entire understanding of cosmic history is flawed. The age of the universe is a fundamental aspect of our understanding of the cosmos, and if that's wrong, then everything else could be up for question. How did galaxies form? How did stars come into being? What role did dark matter and dark energy play in the evolution of the universe? All of these questions depend on an accurate understanding of the universe's age, and if that's wrong, our entire framework for understanding cosmology might need to be rewritten. As scientists grapple with these new discoveries, some researchers are revisiting old theories that were previously discarded. One such theory is the idea of tired light, proposed by the Swiss astronomer Fritz Zwicky in the 1920s. Zwicky suggested that the redshift observed in light from distant galaxies could be explained by the loss of energy of photons as they travel through space, rather than being a result of the universe's expansion. This theory was largely ignored at the time, in favor of the expanding universe model championed by Edwin Hubble. However, Zwicky's tired light hypothesis is gaining renewed interest in light of the latest findings from Webb. If the redshift of distant galaxies is not due to the expansion of the universe, but rather to the loss of energy by light over vast distances, it could have profound implications for our understanding of the universe's age and its expansion. In recent years, a researcher named Rendra Gupta has taken Zwicky's tired light hypothesis and combined it with the idea that fundamental constants in physics, such as the speed of light and the gravitational constant, may not have remained constant over time. Gupta's theory suggests that these constants may have varied over the history of the universe, which could explain some of the discrepancies observed in Webb's data. If this theory proves correct, it would not only revolutionize our understanding of the universe's age, but it could also lead to a complete rethinking of the laws of physics themselves. Gupta's work is particularly significant because it provides a potential explanation for the anomalies observed in the angular expansion of galaxies. Astronomers have long noticed that galaxies at higher redshifts appear to be expanding at an unexpected rate. Normally, we would expect that as galaxies move farther away from us, their angular size should decrease. However, at certain redshifts, galaxies appear to be expanding instead of shrinking. This has led some scientists to question the assumption that the universe is expanding in a uniform manner, as predicted by the Lambda CDM model. Gupta's theory, which incorporates the possibility of varying physical constants, offers a potential explanation for this phenomenon, and it could provide the key to understanding the true age of the universe. If Gupta's theory holds up under further scrutiny, it would mean that our current understanding of the universe's age is drastically incorrect. Instead of being 13.8 billion years old, the universe could be as much as 26.7 billion years old, or even older. This would fundamentally change our understanding of cosmic history, and it would have profound implications for everything from the formation of galaxies to the evolution of life on Earth. It would also open the door to new theories and ideas about the nature of the universe, dark matter, dark energy, and the fundamental forces of nature. As we continue to explore the universe and make new discoveries, it's clear that our understanding of the cosmos is still in its infancy. The discoveries made by the James Webb Space Telescope are just the beginning, and they are already challenging some of the most fundamental ideas in cosmology. The age of the universe, once thought to be a settled question, is now a topic of intense debate, and the answers may be far more complex than we ever imagined. In the coming years, as more data is collected from Webb and other telescopes, we are likely to learn even more about the true nature of the universe. Whether we are on the cusp of discovering a new model of cosmology, or whether we are simply seeing the first hints of a deeper mystery, one thing is certain: the universe is far more mysterious and awe-inspiring than we ever could have imagined. And as we continue to explore its depths, we will undoubtedly encounter even more revelations that will force us to rethink our place in the cosmos and the nature of reality itself. The age of the universe may not be what we thought it was, but that doesn't mean the answers are any less fascinating. In fact, the possibility that the universe could be much older than we believed opens up a whole new world of questions and possibilities. It's an exciting time to be a part of the scientific community, and the discoveries of the James Webb Space Telescope are only the beginning of what promises to be a revolution in our understanding of the universe. The truth about the universe's age may still be out there, waiting to be discovered, but one thing is clear: we are on the brink of a new era of discovery, and the mysteries of the cosmos are more thrilling than ever.